experiment 10, part 1. Did you get the equation for part 1? Is it the equation or derivation of the equation, or just in? Yeah. So what we want is we want the molarity of sodium hydroxide. And so we need the moles of sodium hydroxide over the liters of sodium hydroxide solution. Okay, and then how about the other part of this equation? Do you have the rest of it? In other words, is it you just need the equation, or just want to know how to derive the equation? If you just need the equation, then I can give you the equation. The equation for the sodium hydroxide is going to be the volume of HCl titrant times the molarity of the HCl titrant. What was the molarity?
It was 0.1.
It was the standard solution of HCl. 0.1182. Is that what everybody has? Everybody should have the same molarity for the HCl. So this was the standard solution from the laboratory. And so from the liters of HCl, milliliters to liters of HCl solution, liters of HCl to moles of HCl, the moles of HCl to moles of sodium hydroxide, because sodium hydroxide is going to react in a 1-to-1 ratio. According to this equation, 1 sodium hydroxide reacts with 1 HCl to form H2O, sodium chloride. And then we just divide it by the volume of the sodium hydroxide titrant. This is the equation. So the only thing you plug in here is the liters of HCl. So you convert from milliliters to liters, and then the liters of sodium hydroxide. Actually, we don't even have to convert those because the conversion will cancel the numerator and the denominator. But it's best just to go ahead and convert it, just so you're in the habit of using liters. These you get from your data table, and then you just plug it in and then calculate it for each run. For part 2, they want something different. For part 2, they want, what do they want? They want the percent, do they want the molarity of the HCl? Or not HCl, acetic acid?
Yes, molarity of the acetic acid.
Okay, so it's the same deal. The molarity of the acetic acid is equal to the moles of acetic acid divided by the liters of acetic acid solution. And so here, the moles of acetic acid we're going to get from stoichiometry. And so we're going to start off with the volume of sodium hydroxide times the moles of sodium hydroxide per liter of sodium hydroxide solution. So the volume, we are going to have to convert that to liters. Now this is going to be from part 1. Part 1. So you just take the average of your 3 best trials. And we're going to use that here. The average of the 3 best trials is going to give you a certain molarity here. Times, in this case, it's a 1-to-1 mole ratio. 1 mole of acetic acid for every 1 mole of sodium hydroxide. Because the equation here is sodium hydroxide plus acetic acid. We can yield sodium acetate plus water, a 1-to-1 mole ratio. So this is gonna give us moles of acetic acid, and then underneath this, we're gonna divide it by volume of acetic acid in liters. So we should get moles per liter of acetic acid. Then finally, they want the percent acetic acid. To get the percent acetic acid, we need the density for that. And so they want the percent acetic acid by mass. The percent acetic acid by mass is you start off with the moles of acetic acid per liter. This is going to use the average of 3 best runs. And so in the top, we want to go to grams of acetic acid. And so in the numerator, we're going to convert that to grams by multiplying by the molar mass. What is the molar mass of acetic acid? 4 hydrogen, 4.04. 2 carbons, 24.02. 2 oxygens is 32.00. And so this is 28, 40, 60, 60.06. 60.06 grams of acetic acid per mole of acetic acid. So we have grams of acetic acid. Now we need grams, total grams. The total grams will be the grams of the solution. And so what we're going to do is we're going to cancel it out. So to cancel out, we're going to use the density of the solution. So we're going to convert it from liters to milliliters. So 1,000. 1 liter is 1,000 milliliters. So now we'll have milliliters of acetic acid solution. What was the density they said to use for the acetic acid solution? They said same as water? If they said same as water, then what we'll just do is this. For every milliliter of acetic acid solution, that should be 1.00 grams of acetic acid solution. Pretty dilute, so this is why they're saying it's the same as water, it's pretty dilute. And so we have grams of acetic, pure acetic acid over total grams, that is the grams of acetic acid solution, and then these are multiplied by 100%. It gives us the percent acetic acid. So those are the 3 calculations you do. Okay, other questions?